Okay, but yeah, we're just going to talk about source control generally and get into a little bit of specifics with Git. It's one of those subjects, again, that it constantly surprises me how few people in the synergy development world actually use real source control. It's more and more prevalent now, but still a lot of people don't. I'm constantly surprised, oh yeah, our source control is we rename the file and copy it to this subdirectory or something like that, or a directory with 58,000 files in, and even reliance on OpenVMS version numbers, and please don't type purge and stuff like that. See, I'm not joking, I'm really not joking. So let's talk about version control a little bit. What is source control or version control? Basically, essentially, it's a safe place to store your code. It's a place to store your code that is versioned. And what does that mean? It essentially means that once you've added some code into this environment, then every little change to that code is going to be recorded in minute detail, along with documentation typically about something that the person has typed in to say, well, why did this code change? It's not only going to do that, but it's going to record who did it, when it happened, why, and so on. It's going to give you the ability to report on those changes, to graphically visualize those changes, to go back at any point in the future and undo those changes, or compare those changes to the current code, or compare those changes to the previous code, and recreate any point in time. That might mean recreating something that some state you were in half an hour ago because you were typing code away and really screwed something up. Or it might be recreating something 3 years ago for version 1.9 because some old customer's got a problem in there and you need to be able to recreate that issue and go fix it for them. That kind of thing. So version control also facilitates multiple concurrent tracks of development. So it's a great way to enable development of new features, development of separate tracks of code for previous releases, using branching mechanisms and so on. So when you release a version of a product, you branch within version control, and now you can go back to the source as it was at that point in time, any time in the future, any number of benefits. I think it's a way of preventing or easing developer conflicts as well. A lot of people cite the resolution of conflicts as a reason why they don't want to go to version control, because they've heard that merging is really difficult and all of that kind of stuff. But the truth is, there've always been conflicts. It's just that if you don't have version control, you don't necessarily even know it's happened. It's just somebody edited a file and somebody edited something else, and their changes in that source file could potentially cause runtime type conflicts. And because it doesn't cause a compile conflict, you don't even know it's happened. It's a way of tightening up the whole development environment. There are essentially three types of source control. The first type of source control is the older style, where you have a centralized environment. And there are really two flavors of this. So with a centralized environment, there is one central repository. Again, the term repository is what tends to be used to represent the master copy of the source code, the database that contains the source code, essentially, or the file system, or whatever it happens to be. So there's one central repository, and each developer typically, not necessarily, but typically has their own working copy of those files. It might not be, it might be that there's one working copy, but then you're not going to be getting a lot of the benefits of a version control system. Some of the centralized version control systems are what are called centralized locking environments. In a locking environment, files must be locked before you can edit them, and usually files are physically prevent you from editing them through being set read-only, although clearly there are ways around that with sufficient privilege. But that lock on a file and the fact that that file is read-only is preventing other people from working on that same source file at the same point in time. And in order to release that file for other people to access, you have to then commit the changes to the central repository, which in turn unlocks the lock on the file. So examples of this older kind of environment are PVCS, SourceGear Vault, Visual Source Safe, a lot of those older, more traditional version control environments. Then there is another flavor of centralized source control called centralized and merging source control environments. So typically with a centralized and merging environment, you don't have any locks. Some of the products in this realm allow you to do locks if you really need to, but it's not the normal way you go about operating the environments. So again, developers typically have their own working copies and are free to edit any files they want at any point in time and make whatever changes they want to their local instance of the source code. And essentially what happens in a centralized merging environment is the first developer to commit changes to a certain file wins, and if anybody else subsequently tries to make changes to the original version of that file, then they're going to have a problem when they try and commit. They're going to have a conflict, and they're going to have to resolve that conflict at that point in time. So the second or subsequent person to come along and try and change the file will lose. Examples of products that do that, the old CVS product. Subversion is probably one of the biggest examples of that. Team Foundation Server can be used in this way. TFS, you can go a couple of different ways, but those are sort of examples of the centralized merging model. And then there's the distributed version control environment. So with a distributed environment, every developer has a working copy, usually. Again, you can apply these things in any number of different ways, but generally speaking, every developer has a working copy of all of the source code. But the thing that's different here is that every working copy also contains a full copy of the entire repository as well. Okay? So what that means is each and every developer gets to work totally autonomously, and they have full access to all features of version control. They can locally commit things, they can locally roll things back. They're essentially doing everything totally locally. And then at some point in the future, through some mechanisms, there will be effort to synchronize those repositories, okay? And apply changes that have happened in this one over here and this one back here and so on. There is no requirement to have a master repository in this scenario, although it's very unusual for that to be the case. Technically, you don't have to have one, but still almost always there is a master repository, okay? Examples of this kind of product are BitKeeper, Mercurial, Bazaar, and Git. Okay, so the more modern environments that a lot of people have either adopted or moving towards. This is what usually happens with a distributed source control environment, a distributed model, but with a master repository. So it's kind of a combination of both, where there is a master repository. That master repository probably doesn't have a working copy associated with it, physical files. So certainly with Git, you can have an instance of a repository that's what's called bare, which means it's just the repository, or a normal repository, which is essentially a repository and a working files environment. So typically the centralized repository is probably a bare repository. It depends where it is, I guess. And then individual developers, again, typically have working copies, which still contain full copies of the repository. Okay? So again, the developers are working with full access to source control. They can locally commit, locally diff, locally revert changes, locally look at history. They can do absolutely everything locally. So they might go through an entire development cycle for a new project. They might create a local branch and do some specific development on that local branch and then merge it back into the master when it's all done and tested, and then push the thing to the central repository at some point in the future when that project's complete. Obviously, how you apply these tools and how you use them can be done in a number of ways. That's just one example. Advantages of distributed version control. I think the biggest advantage is it's extremely flexible. It's very configurable, and you can apply it in any number of different ways with different topologies. So even though it is a centralized version control system, a distributed version control system, if you wish, you can still implement it as a centralized one. You could just have one Git repo on a Linux box, for example, with one working copy, with all of the developers working in that same environment, the same way we traditionally worked on a multi-user system like Linux or VMS, and they can all commit and roll back and work in that one environment. That would be extremely unusual. It's like, why would you take a distributed system and turn it into a centralized system? But it's absolutely possible. One thing that is common in some environments is you can set things up as a hierarchical environment. So for example, what I'm getting at here is your application being broken up into subsystems. So you might have a repository for your general ledger environment, and a separate repository for your payroll, and a separate repository for your accounts receivable, and a separate one for accounts payable. And then there might be one master repository which represents the whole product. So you can do sort of subsystem-based development and develop something in the subsystem, and then maybe as part of a main release of the product, merge all of those changes up into the central repository. I don't think that's that common with line of business type software. That's the way, I think it's commonly used in companies who are maintaining Linux operating systems and stuff like that. I think that's typically how they utilize these tools. Generally, these tools are used in a full distributed way where developers commit changes locally and use the benefits or the power of version control locally, and then periodically push changes to a central repository at certain points in time which are defined by their working practices. So, perhaps at the end of a certain development sprint, perhaps after they've fixed a certain bug or implemented a certain new feature, and so on. One of the biggest benefits of distributed version control is backing them up is extremely easy, because you just simply create a clone of the repository somewhere else in the world and keep the two things in sync. And I'll show you that in a graphical way in a moment. So Git itself is just one implementation of a distributed source control system. It was created back in the mid-noughties by Linus Torvalds, the guy that created the original Linux kernel. And as I mentioned previously with the generic distributed systems, each Git directory on every computer is a fully fledged repository. For me as a developer, this is superb. I came from, I used PVCS a long time ago. I moved to SourceGear Vault, which is the centralized locking model. Then I moved to Subversion for a number of years, and I loved Subversion, and the not having the requirement to do locks and unlocks was fabulous. But the biggest problem I had was every now and again I'd close my laptop lid, walk off and get on an airplane. And my Subversion repository is on some server somewhere, and I'm now disconnected from it, and I can't do anything with version control. Because my local working copy is a fully fledged Git repository, I still get to do everything, even when I'm disconnected at 37,000 feet. So it's really amazing. Typical Git hierarchy, as I say, this is not a hard and fast rule by any means. There are any number of ways of configuring your hierarchy, but I think this is probably something fairly typical for the kind of environments that most of us work in. And that would be that there's probably one development master repository, and then individual developers have their own working copies of everything, including their own repositories, and they work locally in their own source control environment, and at the end of a certain development effort, everything's committed locally and then pushed up to that central server. And then very frequently, I would say, that might all be on-premise, so the development master might be just sitting on a Linux box or a Windows box somewhere, yet the development backup very typically might be out in the cloud, possibly on GitHub or GitHost or Bitbucket or any one of those online cloud services. And that's certainly the way I develop with things. I have master repositories on my laptop that has everything, and then I have individual repositories for individual projects, and then the whole thing gets pushed out to GitHub as I commit things and backed up. Some of it's public, some of it's private. That's basically the way I work, and it's very, very straightforward. A more complex hierarchy might be something like this. You might use Git repositories in your quality assurance process as well. So, the left part of the diagram there is what I just described, where you have the on-premise master and individual developers with individual working copies and a cloud backup of that possibly. And it might be that at certain periods in time, that master repository is either pushed over to or pulled from or pulled into the QA master. So as things go from development into QA, maybe certain branches are moved over into that QA environment, and QA are able to operate in that world. And maybe as features get implemented, maybe those branches that represent those new features get pulled over into a production repository that represents the state of the source code as it currently is in production. You don't have to do it this way, but that's one way of operating. And maybe all of those things have their own appropriate cloud backups as well. Obtaining and installing Git, very briefly on Windows, lots of different options. You can get it in any number of ways. Git for Windows is available from lots of places. A lot of people, like with Subversion, there's a Tortoise Git client that integrates with Windows Explorer, and that's the way I work some of the time. I tend to use a combination of Tortoise Git and Visual Studio, depending on how I'm feeling and what I'm doing and what kind of project I'm working on. So Git for Windows is a command line tool. Tortoise Git is a graphical tool that integrates into Windows Explorer, and Visual Studio has really, really excellent tooling for Git that you just check the Visual Studio tools for Git during the installation, and that can also provide the command line tools as well if you check that appropriate box. So it comes from lots of places. On Unix, Linux, OS X, places like that, typically Git is available through that operating system's package manager. So you're going to use Yum or APT or whatever it is. There's a package out there that typically is called Git Core that you just install with the package manager. On OpenVMS, on Integrity at least, there is a Git client that one of the guys at VSI has produced. I have downloaded it, I have not tested it beyond. I did unzip it, and I was able to do a Git clone of one of my GitHub repositories, and it did pull everything down. So beyond that, I don't know how well it works, but there is potentially a Git client. I'm not going to go into a huge amount of detail on configuration because Git is a very extensive product set. The basics will just work out of the box, but there's all kinds of configurations you can do. The point of this slide really is just to make you aware that there is a 3-level configuration thing that goes on in Git. There is a system level configuration, so in program files x86 in a single location, for example, or in etc git config on Linux and Unix, there's a git config file that is system-wide and provides defaults. There's also a user level thing that's typically in a .git config in your home profile, so user profile or home directory on Linux and Unix. And anything in your user profile overrides anything at the system level, and there's also a repository level configuration as well. So you use the git config command to configure things. If you're using a tool like Tortoise, there are graphical UI ways of doing it as well. But depending on whether you use git config minus system, minus global, or without any switches, just be aware that you're configuring different levels of things. There are 3 key areas to working with a Git repository. One is the repository itself, the database of information that represents, what's going on. Typically, you don't need to touch it or go anywhere near it. The repository actually lives in a hidden folder below wherever you create it. So you'll find a .git folder that is then hidden on the various operating systems. And within there's a whole hierarchy. Really, the only reason you should be poking around in there probably is potentially you could edit the config files manually, but probably better to do it through the command line tool so that at least you're doing things correctly. Just be aware that it's there. The second area is the working copy, and that's basically on-disk directory structure that contains the working copy of everything in the environment. And the third thing to be aware of is within the repository, there's something that's called the index. It always seemed like a strange term to me. That's what it's technically called. Essentially, it's a staging area. So what happens is, if I check out a copy of a repository and I'm totally in sync and I haven't changed anything locally, so my working copy files are totally in sync with my repository, my staging area is empty, my index is empty. But if I edit a file in my local working copy and make a change, well, my index will still be empty. Essentially, I can choose, let's say I've edited 5 files, okay, and I want to commit those changes. Technically, the way that works is I first have to stage those changes, and what that does is involves putting them into the index area, and then I commit those changes. So it's a 2-step process, okay? So just be aware that there are 3 states a file can be in: unedited, staged, and then it's committed, okay? So that's what that index area is all about. Some of the tools, you'll see it. I'm going to do a command line demo in a few minutes' time, and you'll see it'll say there are unstaged changes. Then we'll stage them, and it'll say there are changes ready to be committed, and then we'll commit them. Tortoise, the graphical client, kind of tends to hide it away from you and treat it as one. Staging and unstaging is checking the checkbox next to the files to say they will or will not be committed, and that's kind of how it does it. So it's kind of a strange concept to grasp. Basic Git operations, assuming a local repository, although most of these are similar when dealing with remote repositories as well. There is a function in Git called init, so these are all subcommands of Git, so git init, git add, git status, git rm, and so on. The init command creates a new repository, so it creates that .git and that whole hierarchy underneath your working copy. And I'll demonstrate most of these to you, well, some of these to you in a few minutes' time. Git add is used to do 2 things. If you git add a file that is not part of the repository, it adds it to the repository. So it's your way of adding a file into version control. If you git add on a file that is in the repository but has been changed, that's how you stage a change to be committed. So add either adds files into the repository or stages them for committing. Git status will show you information about your working tree and is everything up to date, or have you got unstaged changes or stage changes and so on. Git rm, again, similar to add, is your way of either unstaging a change, okay, or removing a file completely from the version control environment. MV is used to move things around or rename things. Git reset also unstages changes. Git commit is your way of committing things, so you've staged things to be committed and then you commit them to the repository. By the way, all of these commands have lots and lots of subcommands and options you can use. These are just the very basics. So git log shows you a log of what's happened, the commits that have happened, the comments that go along with them, and so on. Git diff will show you differences between a certain revision and a certain point in time. Again, you would use command line options to say, I want to compare the current version of the file in my working copy to the last revision checked in, or to this revision, or to this version, or lots of different options. And Git checkout is your way of restoring something in your working tree back to its checked in value. So if you have a file that you edit and make a bunch of changes and totally screw it up, Git checkout of that file essentially throws away your changes and checks out the currently checked in version. So it undoes, it reverts essentially back to the checked in version. Just a little bit of information so that when you see this weird stuff, you understand what's going on. In non-distributed version control systems, revisions are currently usually represented by, 1, 2, 3, because it's a sequential thing. So every time you commit to a subversion repository, for example, the whole repository goes to version 497, 498, 499. In Git, SHA-1 hashes of the commit are actually used to represent the commit. So the name of a commit is something like this. Very often you'll just see the first 6 or 7 characters used to represent it. And it really has to be that way, or it has to be something different. You can't use a linear system in a distributed version control environment, because I'm committing over here in my local repository. So if I were using 1, 2, 3, but Albert over here is also committing, so 1, 2, 3, what happens when those all get merged into the center? So it can't be a linear scheme. Okay, generally that only really matters if you're dealing with the command line tools. Generally the graphical tools do a great job of showing you histories and making it obvious which one's which, and it's pretty rare to work with the command line tools, certainly if you're on a Windows environment. There's also a way of ignoring files. So there's a couple of special file names, but one of them that I'll talk about is called .gitignore. So a .gitignore file in the root folder of a working copy or the root folder of a repository basically allows you to define patterns of things that should be ignored. So for example, object files, binary files, data files, temporary files, whatever it is that you don't want to be. If a file appears in your working copy, Git is going to tell you, oh, you've got an untracked file, you should be adding it. So this is your way of saying, no, I don't want to track object files and DBRs and ISAM files and things like that. You can put all kinds of patterns in there, and you can use regular expressions and all kinds of things. And most of the graphical tools, again, have ways of helping you manage the contents of that file. I'll show you that a little bit later as well. It's fairly common to develop a standard gitignore file that has all of your common patterns of things that you never want to check into version control, and then just drop that gitignore file into the root directory of the repository when you create it. Also GitHub, if you create a repository on GitHub, it will offer you, do you want to add a gitignore file to this repository? And it offers you lots and lots of standard template ones. And the one for Visual Studio is very, very good. It has most of the stuff. So if you take the Visual Studio one and then add things like star.elb, star.olb, dbr, dbp, the common synergy extensions to it, you're usually in great shape. There is also a global gitignore file as well. So you can, at the system level, you can specify an ignore pattern of things that apply to all repositories on your environment. And that's a good question. It brings up a good question of what should you be checking in, not just to Git, but to any version control system. In my opinion, I want to be checking in anything that is source code. Okay, and that doesn't necessarily mean DBL source code and C# source code and VB source code. It means anything that is the ultimate lowest level thing that is required to create my application. Okay, so for example, repository schemas are a good example of something that I would check in. I would not check in typically repository ISAM files. Typically I won't check in any ISAM files. I would check in an XDL file that allows me to create the ISAM file, and a sequential file that contains data for the ISAM file for my test environment perhaps, but not the ISAM file itself. Now, having said that, some of my public repositories do have ISAM files in them right now, but I'm gradually putting my own rules in place as I go. So typically things that let you create the ISAM file, not the ISAM file itself. But make sure that, in my opinion, your goal with version control should be to have usually nothing in binary format in there, other than possibly documentation, Word documents and things like that, possibly. But from the application's point itself, you should be able to go to the repository, the master repository, wherever it is, clone a copy of that repository on your machine, and build your entire application and be missing nothing. Okay, if you can't do that, something's wrong. Okay, so put some thought into that. You might have to run a couple of scripts like I did this morning. I cloned the SQL example and I ran a script that populated my repository and loaded the sample data files and things like that. If it's a disaster, if this working copy gets destroyed, something's wrong. Okay? And generally, don't be checking in things like DBOs, OLBs, ELBs, DBRs, DLL, anything binary, again, other than possibly things like Word documents for documentation. There is also a way of cleaning up a working copy. Git clean, and there's various options, so like -fx -d pretty much I use. And what this does is it will remove any additional files that are in the working copy that are not checked in. So in theory, assuming you've got your version control correct and you've got everything you need to recreate your app, it should be safe to do a clean. Assuming you've committed changes and assuming you've added any new files as they're added and things like that, I think it's a problem if it's not safe to do a git clean at any point in time. Okay, and that's something to think about when you're designing what you're going to check in and not. Branching and merging. Branches represent a particular line of development. By default, Git repositories always have a single main branch, and that branch is called master, and you'll see that showing up in Git status commands and so on. And you can add additional branches as necessary to do things like new feature development, perhaps. You might create a branch to develop a totally new feature. You might develop a branch to go fix a bug. You might develop a branch when you release a version of a product. So some of those branches, if you're fixing a feature or fixing a bug, the idea might be to branch, write the code, and then merge that change back into the main master branch or some other branch when that thing is complete. Other branches may be permanent. For example, here you can see there's a 1.1 branch at the bottom left there and a 1.2 branch. So that's used to track the version of the code as it was at that release. The idea there is possibly that they will never get merged back in. You might do some development as a bug fix and then merge that individual thing back in, but not the branch itself. Basic branching and merging. The git branch command creates a branch. Git checkout is used to switch to a different branch, so that basically you check out the name of the branch and it switches all the files in your working copy from the branch that you were in to the branch that you're now in. And the git merge command is used to merge things back. And I'll show you a simple example of branching and merging when I go through my demo in a few minutes' time. Conflicts happen. Even without source control, conflicts happen. Now, at least you will absolutely know that they're happening. Okay? Before, potentially you didn't know. If you get a conflict, someone has to do a merge, essentially, or someone has to undo something and redo the work they've done after they've got the latest version, but really kind of different ways of doing the same thing. So all conflicts require a merge. That merge sometimes can be automatic. If changes are made in a completely different area of a file, then sometimes the tools, depending on the tooling you're using, might merge those changes automatically. Sometimes it might require some manual intervention. Certainly if two people have edited the very same line of source code, then someone has got to look at that and decide what to do. And depending on the tools you're using, it can be hard or it can be easy. The tooling in Visual Studio makes it extremely easy. So when you see a merge, you can either decide not to merge. You can say, okay, I'll undo my stuff and go to the latest copy, or you've got to resolve whatever conflicts are there. Working with remote repositories. A remote repository is just a relationship between two repositories. In Git, you declare a remote relationship. So for example, if I have a local repository with a master copy, my local repository typically would know that it has a remote, and that remote has a certain name, and I can then push things to that remote repository. Generally, that doesn't work in both directions. I clone or fetch or pull things from a remote repository and push things to it, but those operations are all driven from me at the lower level. Typically, the master repository doesn't know anything about me. Basic Git operations when dealing with remote repositories, the clone operation is basically saying, there's a remote repository out there, go pull a local copy down to me. You saw me do that this morning when I said, okay, I've got this thing on GitHub, git clone and the URL of the repository, and it downloaded a copy of the whole thing. Not just the source code, I've now got a local copy of the repository. And when you do that, that remote relationship is automatically configured. So your local copy knows that the remote is out there. You may or may not have permission to push to the remote, but you certainly can pull from it if you want to update or get your working copy in line with changes that have happened on the master. Typically, if you go to GitHub and just clone a copy of anybody's repository, which if it's public, you can do that, you now get a full copy, you can do full local version control on it, but you can't push back to them just because you decided to, unless you're a contributor. Okay? If it's a repository that you have access to because you've been made a contributor, then it's a two-way thing. The operation called fetch is a way of retrieving information from the remote repository to say, tell me about things that I've changed out there that if I did a pull I would get. So you can retrieve information about what has changed, but without actually pulling the changes. Pull pulls the changes down from the remote to your local system, and push, if you have permission, pushes changes up there. You know, you might push all changes, you might push specific commits, you might push a certain branch. There's all kinds of different options within all of these environments. Cloning in a repository, again, probably don't need to go into a huge amount of detail here. You saw me do this morning. Git, clone, and the URL of the repository. And optionally, by default, it will create a subfolder with the name of the final part of the repository URL, the name of the repository, or you can specify the name of the subfolder that you want it to go in if you want it to be something different. Like I say, that does pull a copy, and it sets up that remote relationship so that you can pull changes that may occur in the center. Very briefly, I'm going to show you a couple of demos. I'm going to demonstrate something in the command line. I'm going to demonstrate briefly Tortoise, just so you've got the idea, and I'm going to show you briefly some stuff in Visual Studio. Workbench does have some basic support for Git, but it basically has the ability to manipulate the Git command line tools. So you would have to install the Git command line tools, and then in project settings, you can go into tools version control setup, and you basically point it at the Git executable. And it does give you basic Git functionality, but it's not a great experience, to be honest, in Workbench. So let's just very quickly look at some demonstrations, just to show you some very simple operations. Okay, so first of all, I'm going to show you just some simple command line stuff. In this directory, I've just got a very simple little environment. I've got a program called hello.dbl. I've got a subroutine called say hello. Hello, just xcall say hello, and there's a hello world message defined in an include file data.def. So 3 source files and a batch file that just builds and runs it. Okay. First thing I'm going to do, and you can see over here, we've got show hidden folders turned on, which normally you probably wouldn't have. So you can see those are the only 4 files that exist in my folder right now. First thing I'm going to do is create a Git repository. So I'm just going to type the command git init. And that created a local repository, so I now have a full version control system available in this environment. There's the repository, there's the config file, like I said before. You really don't want to be poking around in here too much. Normally you wouldn't even see this, because normally you would have show hidden files turned off generally. So we've now got a version control system up and running. In fact, if I go up a level and look at the folder, you'll see that there's a green check mark next to it. That is Tortoise Git saying there's a repository here and everything's up to date. Okay? Sometimes it's a little bit slow latching on to new repositories and new information. I should have those green icons on these files as well. But sometimes it's a little bit sluggish in figuring out what's going on. Anyway, if I were to do a git status, what it's going to tell me is I'm on branch master, that's the default branch. I'm on the initial commit, so this is a brand new repository, and there are untracked files. The untracked files are data.def, hello.dbl, and so on. They're showing up in red there. So untracked files are not part of my version control environment. Okay? They're just present in the directory. Okay? So the first thing I would want to do is probably add those files in. So if I say git add asterisk, or I could do them individually, that has now added those files into my environment. So now git status is telling me I'm on the initial commit. There's no untracked files, but there are changes to be committed. Okay? So by doing the git add, I have staged those things to be committed, and they're waiting. So the next thing I would probably do is commit those changes. To do that, I'm going to say git commit, and normally you have to provide a message, and I'm just going to say added files. So that's the message that's going to be committed along with these changes in the repository. And it's confirmed there, it said 4 files changed, and it's given me a list of the files that have been added. If I now do a git status, it will tell me I'm on branch master, there's nothing to commit, so no changes have been staged, the working directory is clean. That tells me everything's up to date. In fact, look, Tortoise Git caught up again now. Oh, of course they hadn't been added before. Sorry, yes. So the green check mark is from Tortoise. We'll look at that in a moment. So that tells me If I've got a remote repository, it doesn't tell me everything's been committed to my remote repository, but it tells me locally everything's checked in, everything's in good shape, I haven't edited any files, nothing's waiting to be committed, everything's checked in. If I do a git log, then it will show me that I now have one commit. There's the SHA-1 hash that identifies the commit. You can see I've got my name, my email address, that's part of the configuration, it knows who I am, and the date and time of the commit and added files. If I use command line options and drill into that SHA and so on, I can get information about the files, and I can look at the state of the files and all kinds of things available from it. But there's a basic summary of what's happening. Now let's build it. If I run the run.bat file, it just compiles and links everything and runs it, and you can see the program said hello. So it ran. You can see in my working copy on the right there, I've now got an object file, a DBR, an OLB, a DBO. Okay? Those are all things that I'm not interested in version controlling those things. Okay? So if I do a git status down here, it's going to tell me on branch master, untracked files, hello, blah, blah, blah. And it's trying to prompt me to say git add to add these things in. Well, I don't really want to. Okay? But we'll ignore those for the time being. What I'm going to do is I'm going to make a change. So I'm going to first of all edit data.def. And I'm going to correct this obvious mistake in the program, and we'll change it to say hello world, and close and save the change. Okay? Now let's see what git status says. So now it's telling me on branch master change is not staged for commit. So it realizes that a file that I am version controlling has had a change but not been staged, and there are still some untracked files. Okay? Let's stage the change for commit. So if we do a git add of data.def, that will stage it. Remember, add either adds a file in or adds an existing file for staging. So now we've got a change waiting to be committed. These command line tools are really long-winded. There's all these stage it and commit it, and the graphical tools are so much easier. You just right-click and say commit all this stuff. But now you can see we've got a change waiting to be committed. So let's commit it, git commit, -m for a message, changed message. There's my login message, or my commit message, and we've committed it, and git status now doesn't know about that anymore because that's now being committed, and it's still telling us we've got 4 untracked files. Okay, to fix the untracked files, let's quickly create a .git ignore file, and in that git ignore file, let's just say star.dbo, star.dbr, star.olb. Anything else in there? I think that's all we've got, isn't it? And let's save that change. So we'll Alt F4 and save changes. And git status is now going to tell us we've got see? Our 4 untracked files have now gone away because it's got a git ignore file that tells it to ignore them. But now it's saying, well, there's this untracked file, git ignore. That we do want to keep around. So now we'd have to say git add .git ignore, and then git commit -m added .git ignore, and commit that change. I'm not going to go any further with the command line stuff. Hopefully you get the basic idea. You git add to add things into the repository. You git commit that. You make a change. You git add to stage the change, and then you git commit to commit the things that have been staged, and so on. Okay, I'm going to make this second part really quick. I'm just going to clean out this environment. I'm going to delete the repository. Just to give you an example, you see I deleted the .git folder. This is now just a working copy. I just wiped out the repository. I'm just back to files on disk at this point in time. I'll leave the git ignore file there because it's still relevant. How you would do this with Tortoise, you basically use Windows Explorer integration, so you get a right-click Tortoise Git menu. One of the options here is create Git repository here, so I can do that. Do I want to make it bare no working directories? No. So we've created a repository, and now look, Tortoise Git is telling me you've got all these untracked files. So if I wanted to commit those changes, I could right-click and say Tortoise Git commit to master. So we get a little dialog. If we show our unversioned files, no, we don't have any. Here's our message, and let's add them in here then. They're untracked files right now, so we'll git add them from here. Now, right, so this is how they're now staged. You put a command in there. This is the equivalent of staging and unstaging in the Tortoise environment. You check boxes to say, no, I don't want to include that one. Commit and push. Anyway, you get the idea. You interact with it basically through the Tortoise Git command, Tortoise Git menus, and lots of options about rolling back and deleting and updating and reverting and all of that kind of stuff. Okay, thank you very much.